So now we're going to create and configure an Azure load balancer. Now, before we get started, it's important to understand where we're beginning, because that's pretty critical to understanding how the load balancer configuration works. So what I've set up initially here is fairly straightforward. I've got a resource group, and within the resource group I've deployed two virtual machines, Web 1 and Web 2. Those two virtual machines each have a very simple website, and you can see I've got the website right here. I've published the IP address, so the firewall rules are in place, and I've got two web servers. Each one has a website. Now in this case the websites are in fact different, but that's on purpose because we want to see how the load balancer is actually moving us between the two servers. In any ordinary situation the websites would be identical, because users that are coming in over the load balancer, you wouldn't want them to see different content, right? So you're not going to use a load balancer for different endpoints. Typically they're going to be identical endpoints. So that's what we've got here, two endpoints. They're both web servers, but I want to be able to distinguish which is one and which is two, and you'll see why as we move through. The second important thing to note is that within this resource group I've got an availability set, and this availability set has both virtual machines in it, Web 1 and Web 2. That's also important because the load balancer requires either a scale set or an availability set to configure the back-end systems that is going to talk to you. You can use a load balancer with an individual VM if you've got a single VM that's got, for example, multiple instances of an application running on it. But in most typical situations, you've got a scale set or you've got an availability set. And the important thing to do with the availability set is when you're creating the VMs, make sure that you join them to the availability set when they're being created. It's not something you can do after the fact, and I've learned that the hard way a number of times. So we've got two web servers. We've got those web servers in an availability set, and that's really all we need to get started. What we want to do is put a load balancer in front of these two web servers. So to do that, we're going to add a load balancer. So go to the marketplace and click add, get the load balancer and hit create. I'm going to give this guy a name. Call this one NLB1. It needs a public IP address. Now I've already got a public IP object created. You can create one here, it doesn't really matter. Use the existing resource group to keep this with everything else. Location is fine, and click create. And so the act of creating the actual load balancer just takes a couple of seconds. So that's now created, and we can go ahead and configure it. So there's 5 elements to the load balancer configuration. We have, first of all, our front-end IP configuration. This is the IP that you're going to connect to from the external internet, so from the outside world. And so this is where you assign the public IP to the load balancer. And once it's assigned this public IP, you can view from in here. So we go to our front-end IP configuration. And we can modify or change it in this location. The next thing we have is what's called a back-end pool. Now this is the collection of resources that are going to be load balanced. So I'm going to create a new back-end pool called web servers, and you can see it's associated with an availability set. The availability set is website, which is the one I pre-created, and you can see it's got two virtual machines that are a member of that availability set. And then we're just going to add those virtual machines in. So web server 1, pick the IP address we want to use, and then web server 2, and pick the IP address we're going to use. And then click OK. And so this will create that back-end pool configuration. So this tells the load balancer which systems it's actually performing load balancing for. So that's created. I paused the recording while it worked. It took about a minute total to create the back-end pool. And you can see it's identifying that it's got two web servers. and eventually it'll record the status of both as running. Right now it's just showing one as running. And so we'll let that refresh a little bit, and then that'll show both as running. So the next thing we're going to create is what's called a health probe. A health probe is how the load balancer identifies if one of those web servers or one of the resources goes down. So we're going to go ahead and add a health probe. And these are done to a couple of different ways. We can do this over HTTP, in which case it can actually go query the website and see if the website's up, or we can choose a port and protocol query. So a port and protocol query is a little more straightforward. It's just checking to see if the port's responsive. A web query, you can actually look at a particular file and use a file on a web server as a determination if that web server is up and running or not. So we'll add a simple port query in. Now this does nothing until it's associated with a load balancing rule. So we got the front end configuration, what we're listening on. We've got the back end configuration, which is where we're going. You can see this one now says it's running. We've got the health probe, which is what we're going to watch. Actually, we'll just wait for this to update. So there we go. I'm just going to click out and click in again. So it should be showing me a health probe. Let's just refresh. There, it came up just as I clicked refresh. There we go. So we've got the probe, which is what we're going to use to determine if the back-end web servers are running. And then we've got our load balancing rules, which basically tells the load balancer to conduct load balancing. So we're going to call this one web server load balancing. We have the front-end address we're going to use, the protocol. We're listening on port 80. The back-end port is 80. Now this is actually useful as well because you could actually listen on one port and relay to a different port in the back end. For example, maybe your website's running on 8080 for some reason. You could listen on port 80, but then when it relays the request back, it can change the destination port. The back end pool, the health probe, and then the session persistence. The session persistence indicates how the client that's connecting over the load balancer, how it selects whether it's going to go between the different web servers. If I go to none, every single session that goes in, every request I make is load balanced back and forth between both servers. So I can conceivably load a single view of a web page and have some come from web server 1, some come from web server 2. Now in most cases you don't want a session persistence of none. We're going to use none in our example here. But in most production cases, you're going to do something like client IP or client IP and protocol, so that when a given user connects to the load balancer, they're going to be connected to one of the web servers in the backend pool, and they'll continue to use that exact same web server, which enables session data to be retained. Now, again, the architecture of the website can determine this a lot. If you have a website that uses session data that's stored in a database, then the fact that you move back and forth frequently doesn't really matter all that much. But if you, for example, store session data in the user session, then you want to always go back to that same server so the user session data remains intact. Now, an example of something that might be contained within the session data is something like a shopping cart. So if I have none and the shopping cart is locally in session data on the web server, I might all of a sudden find my shopping cart empty. I refresh again, now it's full. I refresh, now it's empty again. So these are just things you've got to take into consideration. If you're working with load balancing for websites or web applications, the developer of that application will be able to help you determine what the appropriate type of session persistence is. So we're going to go ahead and click OK. And it'll save that load balancing rule. And so that rule is now created. And so we can click on it and we can look at it. We can see what the IP address is and just make modifications if we need to right here. So let's go ahead and just kind of test this rule and make sure that it's intact. So I'm going to come back and just get some of these other windows out of the way. And I'm going to grab my other browser window. And we're going to go to the load balancer's IP address, 40.121.195. 137. And we'll see that we've been redirected to Web 1. Now, if you look closely, you'll see that we're using no session persistence, but if I click refresh, I still go back to boom, boom. That's the reason, or the reason for that, I should say, is this idle timeout value. Now, the idle timeout means is it will maintain the session until the session's been idle for, and in this case, 4 minutes, which is the minimum value. So even though the session persistence is set to none, we're not going to see it go to the other backend web server until it's been idle for 4 minutes. So what we're going to do is wait 4 minutes and see what happens. So if you look at the clock, and you'll notice it's quickly going to step forward about 4 minutes. So 4 minutes has now passed. And if we do a quick refresh, you'll notice we're redirected over to Web 2. So that's how our session persistence works. Now, if I were to choose client IP as an option, it wouldn't matter how long I waited, even though the idle timeout, because my IP address hasn't changed. So it's going to use the IP as the basis for which node I get redirected to. So that is a network load balancer within Azure. Pretty simple, pretty straightforward, easy to set up, easy to manage. And of course, everything we did in here in terms of deployment, we did this via the portal. You can also do via PowerShell and via an ARM template.